All right, we're going to do a factoring technique here called the substitution method. The reason that we're looking to use the substitution method here is because I noticed that my exponent in the middle is half of the exponent on my leading term. All right, so whenever you've got a trinomial and you notice, hey, the exponent for this one is twice that of this one, that's whenever you're clued in, hey, I can use the substitution method, okay? So the way it starts with is you're going to say u equals x squared. And I'm getting that from my middle term there. And what that means is that u to the second power, well, if u is equal to x squared, then u to the second power would equal x to the fourth. And so you see how you match that up and you match that up. Now we can actually do a substitution for this expression. Instead of an x to the fourth, I could say, well, that's just u squared. All right, instead of saying negative 7x squared, I can say that's minus 7u, and then plus 10. And now this is something that's easily factored. We just find two numbers that multiply to 10 and add up to 7. So u times u gives me u squared. This is going to be a 2 and a 5. They are the same signs because it's positive 10 and they're both negative. Cool. All right, last thing you would do here is substitute back in your x squared. Replace that u with an x squared now. So it's x squared minus 2 and x squared minus 5. Cool. And that one is complete. Ta-da, ta-da, ta-da. All right, again, this exponent here, this term, is half the term here. It's half the degree there. So I'm going to say u is equal to x to the third power. That would mean that u to the second, well, you would multiply this thing by itself, and that would give you, oh, not u, that would give you x to the sixth power. All right. So to replace the x to the sixth, I'll say u squared. And to replace the x to the third, I'll just say u minus 12. All right, now this thing will factor. We want u times u to give me u squared. I need two numbers that multiply to 12 right here, and they have to subtract to give me 11. That's 1 and 12. Let's see here, different signs, and the bigger number is going to be positive. Got all that. We'll substitute our x cubed back in. That'll say x to the third power minus 1 and x to the third plus 12. Nice. All right, so this is true, but this thing will actually factor a bit more, just a little bit more, sorry. This right here, this is going to be difference of cubes, all right? 1's a perfect cubed, and x to the third power is a perfect cubed. All right, 12 is not a perfect cube, so I can't do it with that one. All right, so my perfect cube formula here, it's going to be a minus b, so that's going to be x minus 1. X minus 1. And then for the rest of it, it's going to be x squared, and then plus, then 1 times x, which is 1x, plus, and then 1 squared, which is 1. All right, so all of this just came from difference of cubes on that. And then I still have that x cubed plus 12. And that is the factored form. This thing will not break down any further.